Okay, so we just finished up the exponential unit, and what we're going to get into now is getting into the quadratic. Okay, so throughout this unit, we should be able to, by the end of it, we should be able to know how to graph a quadratic, being able to find the zeros, being able to find the axis of symmetry, and identifying all the parts of a parabola. Okay, but before we get into all that stuff, we're going to get into just the intro of quadratics. So our objective for today is to be able to identify the parts of quadratic equations. So if you haven't done so, go ahead and copy this down in your notes, and I'll give you guys about 20 seconds to do so. All right, so let's go ahead and talk about the quadratic terms. So the very first term that we're going to talk about is a parabola, okay? So a parabola is just a graph of the quadratic equation, and what it is just a U-shaped graph. And what it looks like, you see in the little picture that right here, but I'm going to draw it out. So we have, there we go. So it looks like this. You could have it going up, or the shape could be going down like so. So once again, a parabola is just a graph of the graph of quadratic is just a parabola, and it's going to be a U shape. So it could be opening up, or it could be opening down. The next piece that we're going to discuss, if I can get it, there we go, is known as the axis of symmetry. Okay. So the axis of symmetry is just a line that divides the parabola in half. And it should be the imaginary line because you're not going to actually draw the line that divides in half, but it's just the line that divides the parabola in half. So basically, in other words, if I were to take it and fold it, it should overlap each other and be symmetrical to it. Now, what you're going to see in some of your guys' assignments is the abbreviation of axis of symmetry. So the axis of symmetry was also known, you could also see it as AOS, okay? It's just the abbreviation of it. It means the exact same thing. So what this looks like is, let's say we have our graph that looks like this. And all it is, it's going to be an imaginary line, and I'll use green here, that divides your graph right in half. And that's it, okay? Now, here's an equation that we're going to be using if you had to find the axis symmetry algebraically, okay? So it's x equals negative b over 2a. And I'm going to talk more about this later on, but right now just make sure you copy down the equation so that way you guys have it in your notes. Okay, the next piece that we're going to talk about is the vertex. So the vertex is the highest or lowest point of the parabola, okay? Every parabola has a vertex, no matter what, okay? So the vertex, so once again, I'll do some drawing here. Oops, went too far. There we are. So let's say we have a graph that looks like this. So once again, I have a graph that's opening up. And I'll have another graph looking like this, okay? So if I'm looking at it and I see that it's opening up, this point right here is going to be my lowest point of the parabola. Well, this is going to be also known as my vertex. Okay? Same thing here. If I have a graph that's opening downward, this is going to be my highest point, and also known as my vertex. So far, we talked about the parabola, we have the axis of symmetry, and we have the vertex of the parabola. Are there any questions or concerns so far with these three terms that you guys may have? Okay. So let's go ahead and continue then, okay? So we talked about the vertex, okay? The vertex is also going to determine whether or not it's going to be a minimum or a maximum. And we already talked about it a little bit, but I'm just going to have you guys put this down again. The vertex, okay, is the lowest point on the graph, which is also known when your parabola is opening up. So it's also going to be known as your minimum, okay? So if I talk about it, or if I draw it out, once again, here's my graph. It's opening up. We have our vertex, which is right here, but we can also call this the min, okay, or minimum. All right. Then we also have our maximum. Oh, what's going on here? Let me just do this. Edit, reset page. Okay. Review. There we go. Okay, so the maximum, once again, is going to be the vertex at the highest point of the graph. So once again, if the parabola opens down, we can be able to find our maximum. So if my graph is opening down, we know that this point right here is going to be my vertex, but it's also going to be my max. And I'm going to do this over here because I kind of erased it. This will be my min. Okay. So now we have our min value, and we also have our maximum value. The other pieces that we need to know or be able to find is our domain and range. Remember, our domain is all possible x values of the graph. Usually when we're dealing with a domain for your parabolas or any quadratic function, your domain is going to be always real numbers. Okay, so I'm going to put this so you guys can have it as your side note just in case you guys forget. But dealing with your domain for parabolas, your domain will always be real numbers. Will always be all real numbers. Okay, so there should be no question, no doubt. If I ask you what the domain is for the domain for a parabola, your answer should be all real numbers. Okay. The next piece is your range. So your range is going to be your all possible y values of the graph. Now this one I can't say all real numbers because remember you're going to have a maximum or a minimum value, which will change up the range, which we will discuss later on throughout the notes. Any questions regarding the maximum, minimum, or domain and range? Okay, let's move forward then. All right, so the properties of a quadratic equation, okay, we need to be able to look at the standard form. All right, so once again, as a review, the standard form is y equals ax squared plus bx plus c. Remember, your a, your b, and your c, they're just coefficients. Those are just numbers. And the reason why this is a quadratic equation is because it's all raised, my highest exponent is to the power of 2. So this is your standard form, okay? So I'm going to put that down so you guys don't forget that. So this is my standard form, okay? Now, looking at the standard form, we should be able to determine whether your graph is opening up or if it's opening down, okay? And what we're going to do is we're going to look at the a value, okay? By just looking at the equation, I should be able to determine that. So if I look at this, I see that my a is greater than 0, or in other terms, if my a is positive. So if my a is positive, I know for a fact that my graph is going to open up, okay? If my a is less than 0, or should I say negative, I know that my graph here is going to open, oops, it's going to open down, okay? So by looking at the A value, I should be able to determine that. So right off the get-go, I should know that my graph is opening up. And what I mean by that, if it's opening up, it looks like this. Or if my parabola opens down, it's going to be like a smile, a frowny face, sad face, and we're good there. Any questions on determining by looking at the A value? So by looking at the A value, once again, you should be able to determine if the graph is opening up or if it's opening down. Okay, so now let's look at this example here, okay? So we want to label and draw the axis of symmetry, the vertex, and the max and min. So I'm looking at the first graph, the red graph, okay? If I want to label the axis of symmetry, remember, the axis of symmetry is a line that divides this graph in half. So if I look at this, it's a vertical line that I'm looking to see if it divides the graph in half. And I see that this right here, if you follow my little tracer, it's going to divide this graph in half. So what I'm going to do here is I'm going to draw a dashed line going straight through this parabola to show that this is my axis of symmetry. And I'm even going to put that. So this is my axis of symmetry. And what it does is saying, hey, whatever happens on the left side, so this point better match this point for your y value, right? So if this is 1 unit high, this point's going to be 1 unit high, this point's going to be 1 unit high. It's going to be symmetrical. All right? The next piece is asking us to find our vertex. Remember, the vertex is basically the lowest or the highest point of the graph. So if I'm looking at this, if my graph is opening upward, my vertex is going to be right here. It's going to be the lowest point of it. So here is my vertex. And since it's my lowest point of the graph, my vertex is also going to be known as my minimum. Whoops, minimum, there you go. Okay? Are there any questions or concerns here? Okay? So if I look at the next graph, which is the blue one, once again, I'm going to do the exact same process, right? I need to find my axis of symmetry, and I'm going to locate my vertex and my max and min. So if I'm looking at this, I see that my graph is not really being generous to me, but I'm going to try to draw this, find the line that divides my graph right down the middle, which is just right here. So once again, it's going to be a dashed line, and I'm just going to indicate that this is my axis of symmetry, okay? So I can let my reader know. And then from here, I could easily identify my vertex, right? So this is my vertex, and since my vertex is my highest point of my graph because it's opening downward, this is going to be known as my maximum. Any questions or concerns regarding the axis of symmetry and locating the vertex and the minimum or maximum? Okay, guys, if there's no questions, we're going to keep moving forward. Now we're going to talk about the roots, the zeros, and the x-intercepts. Remember, these all mean the exact same thing. Okay, so if I ask you to find the roots or the zeros or the x-intercepts, I'm really just asking you to find what are the solutions to your graph or your equation. Okay, so what this means is those are the terms just used for the solutions of the functions. Okay, the solutions are your x values where your graph crosses your x-axis. Okay, that's the key part. I want you guys to like circle this, right? You want to see where your graph crosses your x-axis because those are your solutions. Those are your zeros, those are your roots, those are your x-intercepts. Now, a quadratic may have 0, 1, or 2 solutions. It all depends on what the graph is doing, and we need to determine that by looking at the graph. Or we could do it by solving it, but right now we're just focusing on looking at that graph. I'm giving you guys time to copy this down before I move on to the next slide. Okay, so let's go ahead and move on to the next slide. So now what we're going to do is I'm going to show you what 0 solutions looks like, 1 solution, and 2 solutions. So if I have a graph or a parabola that has 0 solutions, that tells me that my graph will never cross my x-axis. And what this looks like is the following. My graph could be opening up, and if you notice, my graph is not touching my x-axis. Or I could have a graph that's opening downward just below the x-axis, and it could look something that looks like this. So if I see a graph that looks like this, I know for a fact I'm going to have 0 solutions because my graph is not crossing my x-axis. Now, if I look at a graph that has 1 solution, my graph or my parabola is going to just touch that x-axis once. It's going to touch it, and then it's going to bounce right back up. And where I see where it touches is right here at -5. Okay? I'm just drawing out a parabola here, guys. I'm just doing an example, so don't ask where that -5 came from. I just drew it. And if I want to make my graph open downward, I could do the exact same thing, just showing where it touches my graph or my x-axis just once. So therefore, it would be just touching once, okay? Now, if I have a graph that has 2 solutions, that means my graph is going to be going through my x-axis not once, but twice. And what that looks like is the following, okay? I'm just going to draw one that's looking up, like so, okay? As long as my graph is going through my x-axis twice, I'm going to have a 2-solution process where my zeros or my x-intercepts are going to be, okay? So in this case, my 2 zeros would be at what, -5 and 5, right? So we're here. So I have 1 0 and I have the other. Now my graph could be opening up or it could be opening down. It all depends on what your graph is doing and if it's crossing your x-axis or not. So once again, we have 0 solutions, right? We have 1 solution and we have 2 solutions. It all depends on what the graph is doing. Any questions or concerns regarding finding how many solutions your graph will have? Okay, so let's go ahead and move on. And what we're going to do now is we're going to identify each part of the graph here, okay? So you're going to have to follow along with me, and from your notes, this is the first graph that we're looking at, all right? So I believe, let me go get a copy of the notes. I'll be right back. All right, so by looking at your notes, I'm going right down the column. The first part is identifying your vertex. Well, remember, your vertex is your lowest point of your graph. And if I look at this, I'm going to go ahead and mark up my, my graph here. I see that my vertex is going to be right here. Okay, so here is my vertex. And what I want to do is I want to label that vertex. And I see that my vertex is at 1, 4. So 1, 4. I'm going to put that over here. So 1, 4. Okay? The next part is asking us, is this a max or min? Well, If this is my lowest point of my graph, I know for a fact that this is going to be a minimum, okay? So I'm going to put min right here, right next to the vertex, because remember, your vertex is your min or your max, and we have to be able to know that. The next part is asking us to find the axis of symmetry. Well, the axis of symmetry, once again, is your line that divides your graph in half. So if I look at this, I see, oops, I thought I picked green. So if I look at this, I see that my graph, my line, is going to go right here. That's dividing this line right in half. And remember, this is your axis of symmetry. Okay? Now, if you notice something, your axis of symmetry is going right through your vertex. So what we can do here is say, hey, if my axis of symmetry is going right through my vertex, I also notice that my x value of my vertex is also known as going to be my axis of symmetry. So what I can do here is I could take this 1 and bring it on over here and say, hey, my axis of symmetry is really saying x equals 1. So there's my equation. Now remember, your axis of symmetry is a vertical line, so it has to be x equals a number. The next part is asking us the zeros, right? How many zeros are we going to have? So if I'm looking at my graph, I see that my graph it's opening upward, and it's not crossing your x-axis. So therefore, I'm not going to have any zeros, right? So I'm just going to put a 0 with a slash through it and say, hey, I have 0 zeros because my graph is not going to be crossing my x-axis. The next part is asking us, is it opening up or down? Well, by looking at the graph, I can see that my graph is opening up, right? But if I didn't have the graph, I'm going to look at my A value, and I see that my A value is 1, which means that my A is going to be greater than 0, which means it's positive. So therefore, I know my graph is going to open upward. But by looking at the graph, I can see that it's opening up, so therefore I don't really need to know that or do that. The next part is asking us, what is your y-intercept, right? So my y-intercept, by looking at your graph, I can see that it's the point where it crosses your your y-axis, right? So if I'm looking at this, my graph is crossing my y-axis at this point right here. So I'm going to just go ahead and identify that this is my y-intercept. So my y-intercept is going to be 0, 5. Now, in your notes, it says the width compared to y equals x squared. What I want you guys to do is cross that out and put domain. Okay, cross that off and put domain, and then create another box, another row below that and put range. I made a mistake and I forgot to fix it before I printed it out, but you guys can do that. So once again, in your notes, cross out width compared to y equals x squared and put domain. And right below that, create another row and put range. So you guys have that. Are there any questions on what I just asked you to do with your notes? Okay. So what we're going to do now is we're going to find the domain and range. Well, in the previous part of our notes, I told you that the domain, when we're dealing parabolas or quadratics, majority of the time, like 99% of the time, your domain will always be all real numbers. Remember, your domain are your possible x values. Okay? There is no restrictions on your domain. So I'm just going to put all real numbers. What there is going to be a restriction on is your range, because remember, your range are all your possible y values. Okay? So if I'm looking at this in my graph, I see, come on, and I'll use, I guess I can use, what color did I use? I guess I can use red here. I see that my graph is opening upward, so it's going to have a min, and I see that it's stopping right here, okay? So therefore, I see that anything above this, I can use my y values. Anything below this, my graph is never going to touch. So therefore, my y has to be greater than or equal to whatever the y value is. Oops, I don't know why it does that. Right? Whatever the y value is of your vertex is going to help you with your range. So whatever your y value is, that's going to be your range. So if it's a min, it's going to be y is greater than or equal to 4. Okay? Because anything above that point, and this should not be dotted, this should, or whatever, it's going to be a solid, right? So this is basically my line where my graph can go to. Now it can equal to 4 because it's actually on that point. Okay? If it was off that point, then you would say that it's just going to be greater than. But in this case, it can equal to 4, and once it hits that point, it's going to go back upward. So we found our domain, we found our range, we found all the pieces. So let's go ahead and do another example. All right. So once again, I'm looking at this. I have the equation y equals negative x squared minus 8x minus 12. Right off the bat, I see that my a is negative. My a is negative 1. So if my a is negative, that means my graph should be opening down, right? So by just looking at the equation, I should be able to identify what my graph is doing, whether it's opening upward or if it's opening downward. So right off the get-go, I'm just going to do this. I'm going to just say, okay, my graph is obviously opening down. Even though I see the graph, I want you guys to be able to look at the equation and be able to determine that as well. So obviously my graph is opening down, which is fine. And now we can just go ahead and answer some of these questions here. Oops. So I have my vertex. Once again, my vertex is going to be either my lowest or my highest point. Since my graph is opening down, this is going to be my highest point. So here's my vertex, which is going to also be my max, right? So my vertex has the point of negative 4, 4. So I'm going to put negative 4, 4 for my vertex. Now, we already said that my vertex is my max, so I'm going to circle my maximum. And now the next piece is I want to be able to identify my axis of symmetry. So once again, my axis of symmetry is the line that divides my graph in half. So I'm going to go ahead and draw my imaginary line right down the middle. And I'm just going to label it so that I know that this is my axis of symmetry. Now notice, once again, my axis of symmetry goes through the point of my vertex point. So it's the x value of your vertex. So in this case, I'm going to take that negative 4. I'm going to bring it on over here and say that my axis of symmetry is going to be x equals negative 4. It's that vertical line that divides that graph in half. The next part is asking us to identify our zeros. Oops. Well, my zeros, I see that my graph crosses my axis not once, but twice. So it crosses it here at negative 6, and it crosses here at negative 2. Okay, so here is a 0. Here is a 0. So my zeros are going to be negative 6 and negative 2. All right, we already did the direction where it's opening. We figured that out from the get-go. The next piece is asking us to find the y-intercept. Well, if you look at this, you notice that my graph, you can't really tell where my graph is crossing my y-axis because my y-axis is right here. Okay? So therefore, we have to do some math here. We know that my y-intercept is 0 and a number, right? So we have to plug 0 in for our x. Well, if I do that, I'm going to have negative times 0 squared minus 8 times 0 minus 12. And if you notice, anything times 0 is just going to be 0, and what's going to be left is going to be the minus 12. So I'm going to have y is equal to negative 12. So therefore, my y-intercept will be 0, negative 12. Now, here's a little catch. From your standard form, your ax squared plus bx plus c, your y-intercept will always be your c value. Okay? So I'm going to put this in red so you guys can see it. So your y-intercept will always be your c value. Okay? It doesn't matter because remember when you're plugging 0 in for your x value, anything times 0 is 0, so therefore all of this will just be gone and what's left is going to be your c. So if you can identify your c value, you already know what your y-intercept is. It's going to be your c. Okay? The next part is your domain. We have already discussed this, that your domain is always going to be all real numbers because remember it's all your x values. Now we have to look at your range. Well, my range, since we have our max, is going to stop at this point, at that line, right? Well, remember your vertex, I believe, was what? Negative 4 and 4. So it's your y value of your vertex, and you're going to bring that down. So it's going to be y. Now it can't be greater than, because if it's greater than, it's going to be above that line. Since it's below that line, it's going to be y is less than or equal to positive 4. So anything below 4 is going to satisfy my range. All right? Any questions or concerns on this example? Okay, let's go ahead and move on. And the last part of this is just being able to determine which following represents a quadratic model. So if I look at the first piece, this first graph, I see that I have a graph that looks like a parabola. And in fact, it is a parabola. So if I see a graph that looks like a parabola, there I know that this is going to be a quadratic model. So therefore, I'm going to say, yes, this is. If I look at the other one, I see that this graph looks very similar to what we just finished off with the last unit, which is known as our exponential graph, right? And I see that this is like a decay because it's falling down. So therefore, this is not a quadratic because this is not a parabola. So therefore, I'm going to say no, this is an exponential. There we go. Okay. Now, this is the part where we have, the next one is a little bit tricky, right? I see f of x is equal to x plus 3 times x minus 2. I don't see, remember, if it's a quadratic, I want to see, let me use a different color here so you guys can distinguish it. I'm looking for ax squared plus bx plus c. I'm looking for that exponent of 2, right, to make it a quadratic. I don't see that as of right now. But if I were to simplify this and multiply this out, you're going to see that you're going to end up with that quadratic. Because if I do x times x, that's going to give me x squared. X times negative 2 will give us negative 2x. 3 times x will give us 3x. And 3 times negative 2, which will give us negative 6. So if I simplify this even further, I'll have x squared plus x minus 6. And this is in my standard form. So therefore, yes, this is a quadratic model. Any questions on that? Because I want to make sure you guys understand what I just did there. Okay, guys, I'm going to move on. So now let's look at this one. I have f of x equals 3x plus 2. If I look at this, I notice that I'm not multiplying or anything. All I'm really doing is just adding or subtracting, right? Well, I want to see, do I have an exponent of 2? Well, I don't. I have an exponent of 1. So if I had this and it's just adding or subtracting, I can't multiply them. So therefore, I know that this is just a linear equation and it's not a quadratic model, so I'm going to say no, it's a linear. The next part is asking us, what if I find the perimeter of a rectangle? Well, if I want to find the perimeter of a rectangle, that just tells me I'm going to be adding all the sides, right? So this is 4x plus 2, this is 3x, right? If I were to add all the sides, I'm not multiplying. That means my exponents don't change, right? So this just becomes 4x plus 2 plus 4x plus 2 plus 3x plus 3x. If I do that, that just becomes 14x plus 4. This looks very similar to what I just did from the previous example. It's a linear function. So therefore, this is not a quadratic. But if I look at the other one, I have the area of a rectangle. Well, the area of a rectangle is A equals length times width. Now I see that I'm multiplying. So if I take these two and I want to find the area of that rectangle, I'm going to multiply them out. And if I do that, I get 12x squared plus 6x. Well, now that I see that I have my exponent of 2, I see that this is going to be a quadratic model. So therefore, I'm going to say yes, this is a quadratic model. Okay, guys, so that's